Today we'll be discussing shortcuts for branch circuit takeoff for electrical estimators. Some of you have the time to be very detailed on your estimates. Others may already be working 40+ hour weeks, and any good bid time shortcuts will help you tremendously, and we're here for you today. So my name is Derek Delaquadri, and I am the president of Vision Infosoft, and Brian Hoffelder joins me today. Brian is Vision's training and software development expert and is leading today's webinar.
Thank you, Derek. As Derek mentioned, our topic for today is branch circuit takeoff. So I'm going to pass on a couple of the shortcuts that I've come across over the years. And first of all, I don't claim to have invented these shortcuts. They're just ones that I've picked up from estimators along the years of teaching estimating software and even teaching estimating. So branch circuits is one of those parts of the takeoff that is very time consuming, very tedious. So it's really has some opportunity to save some time. First of all, what is a branch circuit? Let me, there we go. Branch circuits are the wiring that goes from typically a sub panel to the actual electrical item that it's controlling. So it's basically anything, any electrical item that's 20 amps or less is what we're talking, the wiring that goes to those items. It could be a switch, it could be lighting, it could be a receptacle, or again, just any other thing that's 20 amps or less. We're talking about the wiring for that part of the job. So the old school method is the way I was taught. You measure every individual run in the drawings the way it's shown, point to point. And again, that's the way I was taught. So I did a lot of my early estimating just doing the very tedious type of takeoff where you measure and count every single circuit, every run in the drawing. The other part of the branch circuits are the home runs. And again, the old school way that I was taught was to take off the home runs as they were shown in the drawings, measure them the way they're shown in the drawings, or lay them out if they're not shown. So here's a couple of the shortcuts. The first one is simply to use an average length per run. Now that might sound like it's a little bit of a too much of a shortcut, but it really isn't. And I'll explain why that's the case. So there's actually a mathematical justification for coming up with the average length of a run. If you take the square footage of the area that you're working in and divide it by the number of, I call it points, but that's basically outlets, a receptacle, switch, a fixture. And you divide that square footage into the number of points and then take the square root of it. That will give you the average distance between points. So in an example here where we've got a 10,000 square foot building and you've got 100 electrical points, again, receptacles, switches, light fixtures, you divide the 10,000 or the 100 into 10,000. That gives you a result of 10, or the square root of that is 10. Let me back up actually. So 100,000 divided by 100, or 10,000 divided by 100, and then take the square root of 100 is 10. So that's the average length in that particular situation where you've got 10,000 square feet and you've got 100 electrical items. The average distance between the points is going to be 10. Now, to that 10 feet, you still need to adjust primarily for vertical distances. That 10 feet is just the horizontal distance between points. So with lighting, you really don't need to add anything because it's all on the same level in the ceiling for the most part. Maybe you have some drops to some items, but for the most part, the lighting is up above. For switches, you need to add 5 to 7 feet to get down to the switch. For receptacles, it's more like 8 to 10 feet. And of course, you need to adjust for ceiling height. You know, that's assuming a 10-foot ceiling or less, and you need to adjust accordingly if you've got high ceilings. Now, that average distance between points is assuming you can go straight from one point to another, like you would with MC cable. You just go, you know, daisy chain everything together. Now, with conduit, you're going to have to run everything at right angles, and that adds about, on average, 25% to your distances. Okay. Now, if it sounds like that's becoming a whole lot of math, the bottom line is, once you do the math here, your average distance is going to come out at 15 to 20 feet per outlet. Again, you still have to adjust for high ceilings. You have to adjust for anything else that's just common sense. If you've got two receptacles up on a roof, you can't use this formula. But if you got a typical commercial office space like this, a school, even a retail space, this 15 to 20 feet works pretty well. Now, that does not include home runs. Home runs are a whole separate thing. Now, as far as entering that 15 to 20 feet into EBM, there's two places you can do that. So I'm going to switch over to EBM for a minute. I'm in the quick branch takeoff module. Up at the top right, I can select either conduit or cable. I've selected MC cable, this one that's highlighted here, and it puts it down at the bottom. And in my case, I have a default of 20 feet, but you can adjust that again according to the situation. Then all you have to do is pick up the assembly. So I'm in the receptacles now, and I've got a duplex, and I've got a 20 amp spec grade, and then you just put in the quantity. Whoops. And then you hit takeoff, and that's all there is to it. Now, that same option is available in fixtures. It's not quite as obvious, but if I go to light fixtures, I've got this fixture F set up, and these same two buttons are on the screen, conduit and wire or cable. And these are all customizable. You can add to the list. You can take things off the list. You can move around the order. You can do whatever you want with them. This is just the way it comes, so to speak, off the shelf. So if I want to use 15 feet per fixture, I just put the quantity down here and hit takeoff. For those of you, again, that are old school, I challenge you to test these numbers. Do it your old school way, do all the manual measurements, and then test it versus these averages. I would even make the argument that these averages are more accurate, because when you're doing a manual measurement, you're going to have to do a lot of adjustments and interpretation along the way, because it's probably not laid out the way it would be in the field. The guys in the field are going to hopefully make some intelligent decisions about the installation and save some links and do as efficient of an installation as possible. So if the estimator overthinks it and does it, the worst, most difficult, lengthy possible way, then I'm not sure that's really a good way to approach it either. Okay, so let's go to part of the whole basis of doing this webinar here was to just get your attention. It's easy for the branch circuit takeoff to amount to over 50% of your takeoff time or more. Yet the overall cost of the branch circuits in your final estimate is usually less than 15%. And actually with MC cable, it's probably less than 10%. So it's just kind of a point that, you're spending a great deal in proportion amount of your time on taking off branch circuits. What's the value? Maybe that time is better spent on other more critical parts of the job. I would argue that feeders are really critical. That's something we can talk about maybe at another webinar. So again, the old school way to do home runs is to measure them on the drawing as the way they're shown. And if they're not shown, you can figure out how you think it should be done. Can't tell you how many times I've sat down with estimators and they say, well, here's how I want to take out my home runs. And they're thinking, I'm the electrician out in the field. I'm thinking about what's the best way to do it. Well, the formula that I came across, this is several years ago now, is based on the fact that what really determines excuse me, the number of home runs is the number of circuits you have for the branch circuiting, which you can get from the panel schedule typically. Now for commercial work, three-phase, you can figure that a good average is going to be 3 circuits per home run. Okay. So again, a sample here is you take the number of 20 amp circuits from a given panel and divide it by 3. That will give you the average, or that'll give you the number of home runs you need. So if I have 30 circuits, I divide that by 3. That means we need 10 home runs. It's a pretty simple formula. Now, the other side of the formula is we need to know how long we're going to use for an average home run. And this is one of the things that I, again, was shown by some estimators who really know what they're doing. Let's say you've got a building that's 100 by 60 feet. You take half of the longest dimension. So in this case, it'd be half of 100 feet and divide it by 2. That's going to give you your average home run. In this case, we decided we need 10 home runs. So our total amount of home runs is going to be 500 feet. So we've got 500 feet. Let me show you where that's put into the formula here. So it's 100 feet divided by 2. That means the average home run is 50 feet times 10 circuits means I need 500 feet of home runs. Now to put that into EBM, you would go into branch circuits. Now one of the assemblies we have already set up for that is under EMT, 3/4 inch with 7 number 12s. So you would put the 500 feet here. You would put in the number of runs, 10. And I like to add 1 J box for every home run. There's a little shortcut for that. You can put in a 4 square box and a blank cover and put in 10 of those. Then you just hit takeoff. Okay. So again, take the longest dimension divided by 2, multiply it by the number of home runs. That gives you your total footage of the branch home runs. And then you put it into the program in the branch circuit takeoff. Again, like I mentioned a few minutes ago, the branch circuit wiring is usually less than 10 to 15% of the job. So with that in mind, I think these shortcuts may help you better utilize your time. And I would even argue, like I said, that maybe there's even a little more accuracy than if you're doing it the old school way of just measuring point to point. So I don't know if we had any questions, Derek.
Well, we have one right now, and maybe others will come in as we cover that. But I
Okay.
feel like you were a professor today. Like you needed a chalkboard going over some of that math.
Yeah,
Uh,
the math isn't as critical. If you, like you mentioned, there's be a recording of the of the webinar from on YouTube. So if you need a review on the math, you can always go pick it up from the video.
Excellent. All right. Yeah, and it actually makes me think while you were going over it just now that a nice hot sheet, like some kind of a single page document we could share on our website at some point. So I'll look into doing that
Sure.
just to kind of lay out the formulas in an easy, glanceable format. Yeah. So the first question, we have another one rolled in. Is there a way to label branch circuits on Takeoff so it's easier to identify in the audit trail? Same question for home runs.
Yes, there is. That's a good question. I'm going to flip back to the EBM screen. So this little option for notes here. So let's say I'll just re-enter that 500 feet, 10 runs. I'm going to add a junction box for each run. And then this little tab for notes. And this is one of the things I always do in classes. I have people put a note on this entry because it's just good to, this is my branch circuit home runs. And that little note appears on the audit trail down here at the bottom of the entry, like a little footnote. You can see that down there at the bottom. So you can put a note on any entry, and then you'll be able to easily identify it in the audit trail. Somebody said, Brian, just to confirm, the building dimension is 100 by 600. So that's the 6,000 square feet. That's not important to the formula for the number of home runs. Or we just need to take half of the longest dimension. Again, we said the building is 100 by 60. So you take half of 100, and that's 50. And then you multiply by the number of home runs, which we said was 10. That gives you 500 feet of branch wiring for 10 runs. So there was two questions about where they apply. They don't apply to industrial. You might be able to apply it to an industrial job if there's a office area that's got kind of typical commercial wiring, but for the most part, that's one of the things that makes industrial work very tedious. You've got to measure pretty much every circuit on the drawing because they're all usually individual home runs, they're all individual equipment. With residential, the problem is we can't combine home runs. You're going to have one circuit, you're going to have a home run for every circuit, typically with residential, because it's single phase. So it doesn't really help us with the calculation of home runs. You can still use the average length on residential. I think probably the average length for residential is more in the 20 to 25 foot range. But for home runs, we just have to put in the average length of a home run for each circuit, whether it's a dedicated circuit or whether it's a circuit for your receptacles that goes to half a dozen receptacles. We still have to calculate the home run on an average for each circuit. So one of the questions was, does the location of the electrical room affect the dimension formula? Not really. I would say no in most cases. So there's another question about understanding the adjustment for the formula. The adjustment to the formula is really to justify that it's going to come out to 15 to 20 feet. If you do the math and it says that the average length between each point is 10 feet, and then you would have to adjust for receptacles by switches by 5 to 7 feet, because that gives you the vertical distance. For receptacles, you'd have to add 8 to 10 feet. So, and again, it all shakes out at the end. It's going to be 15 to 20 feet per item. The adjustment is important if you want to check the math, but the whole idea is that the 15 to 20 feet is gonna hold true for most commercial jobs.
You're going through these so fast. I'm trying to make sure that we cover all the questions. Are you
Question about
covering
yeah, so far the last one was, what if there are multiple electrical rooms?
them? Mm-hmm.
Again, it still doesn't matter because you're doing it for each panel. If you've got a panel in one room and you do the calculations for the circuiting in that panel, and the same thing on the panel in a different location. The question was, are points the beginning and end of a branch circuit run, or just one end? The point is the outlet. Again, the outlet would be a switch, the outlet could be a receptacle, the outlet could be a fixture. We're counting electrical items that need to be wired. And then we're trying to come up with the average distance between those.
There's, you see Michael's comment?
Michael.
He said, I do each of the outlets and lighting separately. Overall, it does typically come out to about 15 to 20 feet.
Yeah. And I think that's not a bad idea. In my class, we do the whole calculation for the lighting, and then we do the whole thing for the branch power. But you could lump them all together. And again, it's probably going to come out in that 15 to 20 foot range. You can usually have a little shorter number for the lighting because most, like I said, the lighting is all on the same level for the most part. It's all up on the ceiling. That's where the lights come from. But with all the branch devices, you have to drop down and go up and down, sometimes through the wall. Sometimes you have to go up and down to get from the next one receptacle to the next one, or to get from a switched up to a fixture. There's always going to be some vertical distances involved.
And Brian asked, you have this screen for receptacles. Would you do the same for switches?
Yep. Switches are in that same part of the program. I think you're still seeing my screen on the EBM
Yes.
screen, Derek. Okay, yeah.
Yes.
When you go back to the categories, there's switches. I would use the same thing for the occupancy sensors down here. And you could switch to a different type of wiring if you need luminary cable, or you need Cat 5 or Cat 6. That's all up in the menu down here. Yep, so I'd use the same thing. I'd use it for receptacles, I'd use it for switches, and I'd use it for lighting.
And can the adjustment for room height be done as an adjustment at the takeoff level?
Yeah, I would just, if you're normally using 15 to 20 feet and you've got high ceilings, and bump it up accordingly. Add another 5 to 10 feet if it's a, 20-foot ceiling or something like that. But again, you'd have to manually add that if you've got, 10 receptacles. Instead of putting in 200 feet, you might put in 300 feet or 350 feet to adjust it. And again, one of the things I would strongly encourage you to do to get comfortable with this is just run some checks. Do a little bit of the takeoff the old school way, and then check it against these shortcuts. I know 98% of the time it's going to come out very close.
There was one, Mark asks, this looks great, but I'm trying to figure out how to include 2 dimming wires for 0 to 10 volt lighting systems.
Okay, so that's pretty straightforward. Again, if you're using this for your lighting portion of the job, instead of using MC cable, you would use luminary cable, because the luminary cable has the 2 extra wires for dimming. So when you're taking off the fixtures, you have this little tab at the end here for conduit wire and cable. And then when you click on cable, you've got the luminary cable, which has the 2 extra 16 gauge wires for dimming. I think that's what the question was addressing, is how do I pick up that? So, for the fixtures where you need the dimming wires, then you can use 20 feet of this instead of 20 feet of regular MC cable. So you still make individual entries for each fixture. We've got 20 type A's and 50 type B's and 60 type C's, but you just pick the appropriate type of wire and use the formula, use the 15 or 20 feet per fixture. So Zach asked a question about adding types of wire to those lists. Yes, you can. You can add to the cable list in the cable takeoff. You can, or if you just want flexible conduit with low voltage wire, you could do that in branch circuits. You have to create an assembly and save it as one of your shortcuts, and then it will be available whenever you go to those conduit and wire buttons.
I think that covers it. I think you did a great job, Brian. Thank you.
Thank you, everybody.